So in this problem, we have a circle and we're being asked to find the time p at when p returns to the original position on the x-axis. What time is that closest to in seconds? So the first thing we can do is write down the values that we are given. We know that the angular acceleration is 0.010 radians per second squared. And we also know that the radius is 2.0 meters. And then we also know that the angle we're working with is 90 degrees, or in pi terms, pi over 2. And then the full rotation, which is the actual value that we're going to need, is going to be 2 pi, because that's just 2 pi is what it's going to take to go completely around the circle, so it can go back to its original position on the x-axis. So now let's do an equation over here. We know that theta is going to be equal to half of the angular acceleration times the time squared. And the value that I said we're using for theta, a full rotation, is going to be 2 pi. So we can just go ahead and plug that in. And we can also plug in the angular acceleration that we also have. So it'll be half times the angular acceleration times t squared. And we don't want to plug the angular acceleration in just yet, because we do need to keep simplifying this problem. So if we move around the half, we're left with 4 pi over the angular acceleration is equal to t squared. And then to only have the time, to only solve for the time and isolate it, we would have 4 pi over the angular acceleration. And now we can start plugging in all the values. So we would have the square root of 4 pi over 0.010. And when we solve this, the inside, it's the square root of 1256, and then the square root of that is about 35. So the answer will be E, 35 seconds.